Today we're going to study inverse functions. Given a function f with domain D and range R, its inverse function, if it exists, is the function f inverse. This is the notation. Take note, do not be confused this -1 exponent to be an exponent of f. The -1 here is only a notation for inverse function. So let us continue. The inverse function, this is the notation with domain R and range D. Another point here is the given function f, the domain D, becomes the range of the inverse function. Likewise, the range of the given function is the domain of the inverse function, such that the f inverse of y equals x if f of x equals y. In other words, for a function f and its inverse, f inverse of f of x equals x for all x in D, and f of f inverse of y equals y for all y in R. These are the steps for finding the function's inverse. Step 1. Make sure the given function is one-to-one function. If f is not one-to-one, then f inverse does not exist. Step 2. Solve for x and write x equals f inverse of y. Step 3. Interchange x and y. Step 4. Find the domain of f inverse. The domain of f inverse must be the same as the range of f. Let's have example 1. Find the inverse function of f of x equals 2 plus the square root of the quantity x minus 4. Step 1. Let us make sure that the given function is one-to-one. If I am going to substitute any permissible values for x, I will always get a unique and corresponding value for f of x. It means this function is one-to-one function. Now, step 2 says solve for x and write x equals f inverse of y. I'm going to copy this function in here, but instead of the symbol f of x, I will change this into y. So we have here y equals 2 plus the square root of the quantity x minus 4. Everything is the same except the f of x. It becomes y here. The next step is we will solve for x. We want this x to be isolated. The first thing to do is to transpose the number 2 on the other side. So the positive 2 here becomes -2 on the left side. And then we want to remove the radical sign. So we will square both sides of the equation. And if we do that, the radical sign here and the power 2 cancels each other. Only the x minus 4 comes down here. Of course, the left side is the square of y minus 2. Again, we want to isolate the x. We will transpose the negative 4 on the other side. So the sign will change. So now it is positive 4 on the left side. And we can see that the right side is x alone. And then we will just interchange the position of the left side member and the right side member, making this x to be on the left side. So you see here we have x equals the square of y minus 2 plus 4. And at this point, we are done with our step 2. We will go to step 3 to interchange x and y. It means to say, using this equation here, I'm going to copy this equation in here. However, for all the x that I see, I will change by y and vice versa. So you see here, the x becomes y equals, and the y here becomes x. So our new function is y equals the square of x minus 2, then plus 4. And then we will return this y into a function notation, but this time it will be the inverse notation. So f inverse of x equals the square of x minus 2, then plus 4. This is actually the inverse function of the given function. Now, for the last step, find the domain of f inverse. We can simply get the domain by taking the range of the given function. Let us observe the given function. We have a constant 2 and a radical here. For the radical, the permissible value for this is from 0 to positive infinity. So it means to say, if the radical is 0, the value of f of x will start from 2 and it will increase when the radical is increasing. So it means to say, the range of this function starts with 2 and going to positive infinity. So for the domain of the f inverse, it is equal to 2, and positive infinity. Of course, we use the square bracket for the 2 and parentheses for the infinity. This is our final answer. Let us have example 2. Find the inverse function of f of x equals the negative fraction. The numerator is 2x minus 3 all over 5. First, let us make sure that the function is 1-to-1. I can observe that this function is linear, so the graph is aligned. The domain is all real numbers, while the range is also all real numbers. Also, if I'm going to put a permissible value for x, a unique value for y will come. So it means to say, this function is a 1-to-1 function. Now we are going to solve for x and write x equals f inverse of y. I'm going to copy again this problem here, but instead of f of x, I will change this by y. So I have here y equals the negative of 2x minus 3 all over 5. And I will solve for x. I want the x to be isolated. First, this 5 I'm going to cross multiply with a y on the left side. So I have now 5y equals the negative of the quantity 2x minus 3. I'm going to remove the grouping symbol, so the negative sign here will be multiplied to each term of the binomial. So negative times 2x will be negative 2x, negative times negative 3 is positive 3. And then this positive 3 will be transposed on the other side. From positive, it becomes negative. So I have now 5y minus 3 equals negative 2x. To simplify further, and I want this x to be alone, meaning the coefficient should be 1, I'm going to divide both sides of the equation by the coefficient of x, which is negative 2. So this negative 2x divided by negative 2, and the other side is 5y minus 3 divided by negative 2. And I can now cancel the coefficient negative 2 and the divisor negative 2. Then only x as positive will come down. The left side will just be same. And then I'll just put this x on the left side, and this left side member will be placed on the right side. So I have now x equals 5y minus 3 all over negative 2. For step 3, let us interchange x and y. It means we will copy again this function. We will write here, but we will change all x into y and all y into x. So you see now, the x here becomes the y and the y becomes x. So the new function here is y equals 5x minus 3 all over negative 2. We will now change this y into function notation, but this time it will be the inverse function of x equals 5x minus 3 all over negative 2. And this is the inverse function that we are looking for. For the last step, to find the domain of f inverse, let us observe the given function. It is a linear function, and we know the domain is all real numbers and the range is all real numbers. So it means to say the domain of f inverse is also all real numbers, and the interval notation is negative infinity up to positive infinity. So this is our final answer. Example 3. Find the inverse function of f of x equals 3x minus 4. For step 1, we make sure that this function is 1-to-1. Notice that whatever value we put for the x, there will be a unique value for the f of x. So this is a 1-to-1 function. Now step 2. We solve for x and write x equals f inverse or y. So we write this equation down here, but instead of f of x, I will use y. So we have y equals the 3x minus 4. Now we solve for x. This negative 4 we transpose to the left. The negative 4 becomes positive. So we have y plus 4 equals 3x. Then we isolate x. We divide the equation by the coefficient of x, which is 3. So the left side becomes y plus 4 over 3 equals the x. We just interchange the position of x and the left side value. So x comes to the left equals the fraction y plus 4 all over 3. Then we go to step 3. We interchange x and y for this equation. That means the x becomes y and the y becomes x. So this equation now is y equals x plus 4 all over 3. Now this y we change as the inverse of this f. So we have f inverse of x equals the right side fraction x plus 4 all over 3. This is the inverse function of our original problem. Example 4. Find the inverse function of f of x equals 2 over x minus 3, then plus 4. Step 1. We make sure that f is a one-to-one function. Notice that if I change this x by any value, there will be a unique value for the f of x. So this is a one-to-one function. Step 2. Let us solve for x and write x equals f inverse of y. That means we're going to rewrite this problem down here. But for the f of x, I will change into y. So we have y equals 2 over x minus 3, then plus 4. Let us now isolate the x. This plus 4 we transpose to the left. It becomes negative. So we have y minus 4, the fraction 2 all over x minus 3. From here, we cross multiply this x minus 3 by y minus 4. Or we say that we exchange position of the two binomials. So the x minus 3 comes to the left, the y minus 4 comes as denominator of the fraction. So it becomes like this. Then we isolate the x. The negative 3 we transpose to the right. The negative becomes positive 3. This is now our equation. Then step 3. We interchange x and y. That means x becomes y and y becomes x. So this equation now is y equals 2 over x minus 4, then plus 3. Now we change this y by the f inverse of x. We have this equation. This is the inverse function of this given function. Example 5. Find the inverse function of the following if exists. We have here three functions. Let's begin with function A. We have f equals 3, 6, 4, 9, 5, 12, 6, 13. Note that this is a function because the x values appears only once, namely 3, 4, 5, and 6. Now we're going to check whether this function is one-to-one. We can see that for every x value, there is only one corresponding y value, namely 6, 9, 12, 13. It appears only once. For that reason, we can now invert the position of the x and y values respectively. So the 3, 6 becomes 6, 3, 4, 9 becomes 9, 4, 5, 12 becomes 12, 5, 6, 13 becomes 13, 6. And this is the symbol f inverse. This is the inverse function for this corresponding function. Then we write this answer below problem A. We go to problem B. The function f equals, elements are 2, 1, 3, 1, 4, 1, 5, 1. Note that this is a function because the x values, namely 2, 3, 4, and 5. Now, we are going to check whether this function f is 1 to 1. Observe that for every x value, there is only one y value, and that is the value 1. See, 2, 1, 3, 1, 4, 1, 5, 1. For that reason, this function f is not 1 to 1. And in that case, this function f has no inverse. So for problem B, we write no inverse. We go to problem C. The function f equals 210, 310, 420, 530. Note that this is a function because the x values appear once only, namely 2, 3, 4, and 5. Now let us check whether this function f is 1 to 1. Notice that we have here 210 and 310. For two x values, which are 2 and 3, there is a corresponding 1 y value, and that is this 10. For that reason, this function is not 1 to 1. So, this function has no inverse. For problem C, we write no inverse.